Okay. So the question here is edit distance. Basically, have to convert word 1 to word 2. Allowed operations are this. Can insert a character, delete a character, or replace any character to any other character. So coming to mastering DP, especially the string ones, how do you recognize whether it's a MP question? So it's easier to find the direct ones like the robber problem, which involves the repeated subproblems. But there is no way to find here. So coming to this, the thing here is think of the subproblems, the substates. So the sequence of this is very hard, but imagine you're at H and R. What can you do about it? If that is a match, you do not do anything. If that is not a match, either you can insert, replace, or delete. So when you insert R to this, you are extending it, and basically you'll solve the existing hordes, but with OR S S OS of rows. So insert here is this, and you have to solve the HORSC with OS again with delete H and R. If I delete H, I still have to solve R, but there is no H. And replace is something, just replace H with R and solve for the remaining ones, which is OR, SC, and OS. So these are the conditions, but how does this represent a DP? Coming here, so it's basically solve the I minus 1. I'll go to the recursion in the other way around, in recursive manner. Basically, if I replace, I'll solve I minus 1, j minus 1. But with delete, I'll solve I minus 1 and j. For solving I minus 1 j, with replace, with insert, I'll get I minus 1 j minus 1, which is a repeating problem. Similarly, for insert, first insert and delete will give me I minus 1 and j minus 1. Yes, this is the moment which states that it is DP. Before that, you should be able to solve it with recursion. The way you solve it, the way you look at it this way, this is the recursion manner, and this must be done for sure the recursive way. To get to the recursive way, you have to think of it this way by taking H and R. If you see H and R, and for I and J, it will be something similar. Okay. The four things that you must be doing is two-pointer mindset using I and J. And then the branching logic, which is how you solve I and J using the lower functions. These logics. And you'll just need to get the minimum of all this. And from here, the DP is inevitable. Branching logic. Next, the base case. So coming to this question. So I have to solve I and J. In this case, at any particular point, if I have same, I just go to the remaining strings. Otherwise, I have three possible cases. Since the character cost, since the operation cost is one for all, just take one for all and then minimum of whatever, all the possible things. So this will be an as one with replace. And for insert, let's say I have H and R. H and R. I'll insert R, or I'll just take H R and insert R. I'll go this is it I, this is it J. Insert R, that will be H is again at I, but R and R, H is at J. We have to solve H, which is I, and then J minus 1. Similarly, for B, for delay. So H and R, I and J. If I just can modify this, right? Word 1 to word 2. So would delete H. Then I'll be left with I minus 1 string. But I do not have any matching for R, which is J. So solve for I minus 1 and J. In the base cases, when I have nothing and I have to make it rows, then I can have 3. Basically, how many I have? Our minimum is all inserts. We can have to make the These are two base cases handling here. And then going back, I just have to do if it is equal, similar to this. It is not equal, similar to this.